parametric form of conic sections. Now, whenever we talk of parametric form of an equation, basically what we mean by that is usually y is equal to a function of x. This is what we talk about. But in case of parametric form, what happens is y would be a function of some other variable, right? So let us say t, and x would also be a function of t, right? So which means y is indirectly a function of x. So let's see how we can look at parabola, ellipse and hyperbola in parametric form. So let's take parabola first. Standard form is y square is equal to 4ax. Now it's the slope of the tangent to parabola at a particular point would be the derivative of y square is equal to 4ax. So this is a little bit of calculus that I am using. So y square is equal to 4ax and differentiate with respect to x. So 2y dy by dx is equal to 4a. So dy by dx is equal to 4a by 2y. 2 2's. So dy by dx, which is nothing but the slope of the curve at a point. So basically it boils down to the slope of the tangent to the curve at a point is 2a by y. Now let's say this is equal to some other variable. So let's say let t is equal to 2a by y. So y would be equal to 2a by t. And now let's substitute this in y square equal to 4ax. So 2a square by t square is equal to 4ax. So 4a square by t square is equal to 4ax. So one of the a's will go, 4 and 4 will go. So we are left with x is equal to a by t square. Some of this doesn't gel properly. Yeah, this is right. Y is a function of t and x is a function of t, but they are ending up in the denominators. So to make it much more simpler, let's say 1 by t is equal to 2a by y. So now what happens? Y becomes equal to 2at. Now let's substitute this in y square is equal to 4ax. 2at square is equal to 4ax. 4a square t square is equal to 4ax. 4a, one of the a's. So x is equal to at square. So here x is at square and y is equal to 2at. So in the standard form it is y square is equal to 4ax. In parametric form it's a combination of these two. So the parametric form is this and t is the parameter. So a point P on the parabola can be represented as x comma y in standard form. In parametric form, this would be at square comma 2at. Now we can prove it very easily. So let's take y square is equal to 4ax. Let's substitute the values of x and y. So 2at square is equal to 4a at square. So 4at square, a square t square is equal to 4a square t square. Parametric equation of an ellipse. Now we know the equation of the ellipse: x square by a square plus y square by b square is equal to 1, where a is greater than b. Let's draw the figure for this. So let us say these are the coordinate axes, and our ellipse is, let's say, is this, and let's now draw a circle. Okay, so we have the ellipse and we draw a circle by making a equal to b. So the equation of the circle would be x square plus y square is equal to a square. Now how did that happen? We took the a square plus a square. Remember, we made a equal to b, so we can substitute b by a, and this is 1, so we take the LCM and take it to the other side. Now let's take a point on this. Let's take a line to the origin and let's drop a perpendicular. Let's say this is Q, this is M, and this is O. So here OM would be equal to X. QM is equal to Y. OQ is equal to radius of a circle, which is equal to the half of major axis, which would be equal to A. Now angle QOM equal to theta. Now in triangle QOM, let's look at OM. We are interested in the X value of Q. So OM is actually the adjacent side. So adjacent side appears in cos. So cos theta is equal to adjacent side by hypotenuse. Now hypotenuse is the radius, so A. So which means OM is equal to A cos theta, and OM is nothing but X. So X is equal to A cos theta. Now that we have X, let's figure out Y by substitution. So we have x square by a square plus y square by b square is equal to 1. A square cos square theta, a square cos square theta by a square plus y square by b square is equal to 1. So a square gets cancelled, y square by b square is equal to 1 minus cos square theta. So y square is equal to b square sin square theta, and the squares we can cancel. So y is equal to b sin theta. So the parametric form of ellipse is x equal to a cos theta, y is equal to b sin theta. So the position of a point P on the ellipse can be written as b a cos theta b sin theta, and proving it is very simple. So x square by a square plus y square by b square equal to 1. Just do the substitutions. A square cos square theta by a square plus b square sin square theta by b square. So b square equal to 1. B square a square gets cancelled. And we know that cos square theta plus sin square theta is equal to 1. So that is ellipse. Now let's look at hyperbola. By the way, theta is the parameter here. Now we have the hyperbola and we have an auxiliary circle. So let's say we have a point P on the hyperbola. Let's drop a perpendicular, let's say M. Let's take a tangent to the circle, auxiliary circle, to the M. So this is normal to the tangent. So let's say this is theta. Now here, this would be A, the radius. Why? Because this is A. Remember, hyperbola cannot exist between minus A and A. So this distance is A. So let P, X, Y be an arbitrary point on the hyperbola. PM is perpendicular to transverse axis. Let us say this is T. So TM is tangent to the auxiliary circle. That is, circle is x square plus y square equal to a square. We just make a equal to b. Okay. Now, in triangle, this is O, origin. In OTM, remember, this is going to be 90 degree. Angle OTM is equal to 90 degree. Why? Because a tangent forms a 90 degree angle with the radius. So now, what are we interested in? We are interested in OM, right? So OM is the hypotenuse in this triangle. So let's take cos theta, and more importantly, what do we have? We have, or we know, A. So A here is OT, right? And OT is the adjacent side. So that is the reason why we take up cos theta. So cos theta is equal to adjacent side by hypotenuse. So adjacent side is A by OM, or OM is equal to A by cos theta, or to bring cos theta to the numerator, A sec theta. Now that we have this, OM is X, so X is equal to A sec theta. So now let's substitute this in x square by a square minus y square by b square equal to 1. So a square sec square theta by a square minus y square by b square equal to 1. A square, so minus y square by b square is equal to 1 minus sec square theta. Or we can remove that negative sign, multiply the whole thing by minus 1. So sec square theta minus 1 times b square. Now y square is equal to tan square theta b square. Square gets cancelled. So y is equal to b tan theta. Now the parametric form of the equation of a hyperbola would be x is equal to a sec theta and y is equal to b tan theta, and the parameter is theta. Now proving it is very easy. So to prove it, again, minus y square by b square equal to 1. Just do the substitution. A square sec square theta by a square minus b square tan square theta by b square equal to 1. A square, b square. Now if you don't know sec square theta minus tan square theta equal to 1, take it a step further. Cos square theta minus sin square theta by cos square theta equal to 1. Take the LCM, 1 minus sin square theta by cos square theta. 1 minus sin square theta is cos square theta by cos square theta. So these two gets cancelled. So 1 equal to 1. So that is the parametric form of conics. So that's it for now. Bye.